हेलो फ्रेंड्स, वेलकम टू माय चैनल मैकेनिकल मेजर। लास्ट वीडियो जो था हमारा वो था हमारा रोलिंग कॉन्टैक्ट बेयरिंग पे। ठीक है, मशीन डिज़ाइन सब्जेक्ट चल रहा है। जो बाकी पिछले वीडियो नहीं देखे उनके लिए मैं छोटा सा एक इंट्रो दे दूं कि हमने अभी तक स्ट्रेंथ ऑफ मटेरियल टॉपिक कंप्लीट कर लिया। उसकी प्लेलिस्ट आपको अलग से मिल जाएगी मेरे चैनल पे। सेकंड, हमारा मशीन डिज़ाइन जो है वो स्टार्ट हो चुका है। मशीन डिज़ाइनिंग में 3 टॉपिक हमारे कंप्लीट हो चुके हैं। फर्स्ट था हमारा क्लास, सेकंड था रिवेटेड जॉइंट, थर्ड वाज योर बेयरिंग्स। तो बेयरिंग्स में हमने रोलिंग कॉन्टैक्ट बेयरिंग कंप्लीट कर लिया है। आज जो हम स्टार्ट कर रहे हैं वो हमारा स्लाइडिंग कॉन्टैक्ट बेयरिंग। स्टार्ट करने से पहले फ्रेंड्स मैं एक चीज़ आप लोगों से रिक्वेस्ट करना चाहूँगा कि जो भी मेरे वीडियोस को देख रहे हैं, जो भी इनके थ्रू ट्यूटोरियल्स के थ्रू स्टडी कर रहे हैं या फॉलो कर रहे हैं, उनसे सिर्फ मैं ये बोलूँगा कि आपको अगर कंटेंट में, एक्सप्लेनेशन में, ठीक है, या जो भी वीडियो से रिलेटेड जो भी आप लोगों को लगता है फीडबैक, वो कमेंट बॉक्स पे आके फीडबैक जरूर दें। कोई एसएससी एग्जाम प्रिपरेशन रिलेटेड टॉपिक से अगर आप लोगों को कोई डाउट है, टेक्निकल टॉपिक जो भी चल रहे हैं उनसे रिलेटेड डाउट है, ठीक है, कुछ भी इश्यूज हो तो प्लीज़ वहाँ आके आप लोग कमेंट कर सकते हैं। आपको अगर कुछ फीडबैक चाहिए, कुछ गाइडेंस चाहिए, तो मैं ट्राई करूँगा कि मोस्ट प्रोबेबली आप लोगों का जो भी डाउट होगा, जो भी क्वेश्चंस होंगे, क्वेरीज होंगे, वो सॉल्व करने की कोशिश करूँगा। ठीक है, अपार्ट फ्रॉम दैट कमेंट बॉक्स आप लोगों के लिए ज़रूरी है। वहाँ पे आके आप लोग जरूर फीडबैक दीजिएगा और फीडबैक जेन्युइन होना चाहिए। ठीक है, अगर आपको लगता है कंटेंट कम है, कंटेंट ज़्यादा है, ठीक है, या स्पीड थोड़ी स्लो चल रही है, स्पीड फास्ट होनी चाहिए, या इन एडिशन टू दैट वीडियोस में और क्या चीज़ें ऐड ऑन होनी चाहिए जिससे आप लोगों को और भी बेनिफिट्स मिल जाए, तो वो प्लीज़ मुझे आप लोग फीडबैक जरूर दीजिएगा। आज का टॉपिक स्टार्ट करते हैं फ्रेंड्स। आज है हमारा स्लाइडिंग कॉन्टैक्ट बेयरिंग्स का। ठीक है, बेयरिंग्स के बारे में ऑलरेडी इंट्रोडक्शन हमने देख लिया था। सेकेंड क्लासिफिकेशन बेयरिंग्स का है, वो है आप लोगों का स्लाइडिंग कॉन्टैक्ट बेयरिंग का। ठीक है, अब डिफ्रेंशिएट हम ये कर लेते हैं फ्रेंड्स की रोलिंग कॉन्टैक्ट, स्लाइडिंग कॉन्टैक्ट। बाय वर्ड्स, इंग्लिश टर्मिनोलॉजी से ही हमको क्लियर हो जा रहा है कि वहाँ पे एक तरह का रोलिंग एक्शन हो रहा है। बाय रोलिंग एक्शन, द रोलिंग एक्शन बिटवीन द बिटवीन द सर्फेसेस। ठीक है, जो भी हमारी सरफेस थी, रोटेटिंग सरफेस एज वेल एज द स्टेशनरी सरफेस, वहाँ पे एक रोटेटरी मोशन हो रहा था। बट इन केस ऑफ योर स्लाइडिंग कॉन्टैक्ट बेयरिंग, the the moving part and the stationary part will have the sliding contact। ठीक है, जो भी आप लोग का स्टेशनरी और मूविंग पार्ट होगा वहां पे कोई स्लाइडिंग एक्शन होगा, एंड डिपेंडिंग अपॉन द दैट वी हैव क्लासिफाइड द बेयरिंग्स एज योर स्लाइडिंग कॉन्टैक्ट बेयरिंग। ठीक है, अब देखिएगा फ्रेंड, हम स्लाइडिंग कॉन्टैक्ट बेयरिंग तो पढ़ रहे हैं, बट जैसे हम लोग हमारा हमेशा का एक क्वेरी रहता है, जो मेरे वीडियोस का क्वेरी रहता है, कि हमारे पास 2 क्वेश्चंस अवेलेबल हैं हर एक टेक्निकल टॉपिक के लिए। द फर्स्ट इज हाउ वी आर रीडिंग एंड सेकेंड इज वाई वी आर रीडिंग। ठीक है, तो ये हाउ और वाई के बेसिस पे हम पूरे हमारे टेक्निकल टॉपिक्स को कंप्लीट करते हैं। तो फर्स्ट इज हाउ वी आर रीडिंग पे हम थोड़ा सा इसका इंट्रो ले लेते हैं। बिकॉज देखिएगा, अगर हम हाउ पे जाते हैं तो पहला चीज ये आती है कि इफ द बेरिंग इज ए शॉर्ट ऑफ योर असेंबली। ठीक है, बेरिंग को अगर एक असेंबली मान के चलें तो वहां पे उनके कुछ एलिमेंट्स होंगे। ठीक है, छोटे छोटे कुछ एलिमेंट्स बन के एक असेंबली बनती है। तो हम हाउ वी आर रीडिंग के क्वेश्चन मार्क को हम यहाँ पे आंसर करते हैं कि वी विल रीड बाय अंडरस्टैंडिंग द वेरियस एलिमेंट्स ऑफ द असेंबली। ठीक है, हर एक असेंबली के एक एक एलिमेंट को हम स्टडी करेंगे, और उस एलिमेंट्स को स्टडी करने के बाद ओवरऑल असेंबली के बारे में हम डिस्कस करेंगे। ठीक है, तो जब हम एलिमेंट के बारे में स्टडी कर रहे हैं फ्रेंड, तो फर्स्ट एलिमेंट दैट कम्स फॉर योर स्लाइडिंग कॉन्टैक्ट बेयरिंग इज यू कैन से द एलिमेंट कॉल्ड एज अ लुब्रिकेंट। ठीक है, और उसका जो एप्लीकेशन है उसको हम बोलते हैं लुब्रिकेशन। ओके, सो व्हाई वी आर रीडिंग दिस लुब्रिकेशन, देखिएगा, व्हेन वी हैव रेड अबाउट द रोलिंग कॉन्टैक्ट्स बेयरिंग, in that case what we are getting, there was a rolling action between the stationary and the rotating part, ठीक है, inner ring and outer ring can say, but in order to reduce the friction, and what was then the main issue for using the bearing is to minimize the friction. Okay, for the rotating shaft, for a rotating member, if you are minimizing the friction, then an element has to be introduced that reduces the friction, and that particular element, or you can say the fluid, is called as your lubricant. Okay, so the same cases with sliding contact bearing. Why we have reading, why we are using the lubricants in order to minimize the friction. Okay, और friction component को reduce करने के लिए हम lubricant use कर रहे हैं. So lubrication is a science of reducing friction by application of suitable substance called as lubricant between the rubbing surface of the body having relative motion. ठीक है, रिलेटिव मोशन में जो भी हमारा जो फ्रिक्शन फोर्स या फ्रिक्शन कंपोनेंट प्रोड्यूस हो रहा है, इन ऑर्डर टू रिड्यूस द फ्रिक्शन और इन ऑर्डर टू मिनिमाइज द फ्रिक्शन, वी आर यूजिंग द लुब्रिकेंट्स। ठीक है, नेक्स्ट इज कि अब लुब्रिकेंट्स, हमने लुब्रिकेशन के बारे में स्टडी कर ली। नाउ व्हाट आर द वेरियस क्लासिफिकेशंस ऑफ योर lubrication. ठीक है, so the first is your thick film lubrication, second is your thin film lubrication and third is your zero film lubrication. ठीक है, एक एक चीज को अगर हम इंग्लिश टर्मिनोलॉजी से पढ़ेंगे फ्रेंड हमारे खासकर बेरिंग के टॉपिक में, तो आपको वहीं से उसका डेफिनेशन क्लियर हो जाएगा. ठीक है, बट एक मेन पॉइंट कुछ ना कुछ रहेगी, दोनों तीनों हमारे जो क्लासिफिकेशन है उनको डिफरेंशिएट करने के लिए वो हम देख लेते हैं, वो हमारा की पॉइंट रहेगा. ठीक है, थिक फिल्म, थिक वर्ड से आप लोग क्लियर हुआ, देयर मस्ट बी सम you can say a layer which is more thicker than the any other classification. ठीक है, so what is this thick layer? When the two surface of the bearing is relatively motion are completely separated by a film of fluid. ठीक है, so when both the elements are completely separated, ठीक है, अगर that may be 2 mm, that may be 3 mm, okay, but if it is completely separated then it is called as thick film. Okay, now second is when the metal to metal contact or there is a partial metal to metal contact. Okay, when there is partial metal to metal contact, you can also say they are partially separated. Okay, so in that case what we are getting, that kind of lubrication is called as your thin film lubrication. Okay, and the third one is a zero film. When no lubricant is present inside bearing is called zero film lubrication. When there is no any kind of lubrication, in that case if the question arises from then from where the we can minimize the friction. ठीक है, from where we can minimize the friction, so we can clearly state that the surfaces what we are using in case of zero film lubricant or zero film, you can say the bearings, that if the bearing has very smooth surface, very less coefficient of friction, then you can say there is a sort of zero film lubrication concept there. Okay, so moving on to next, you can see here, यहाँ पे हमको एक चीज देखने को मिल रही है जो रेड में हाईलाइटेड है. ठीक है, जो वीडियो पहले वीडियोस नहीं देखे हैं या वीडियो से स्टार्ट करें उनको बता दूं, जो भी नोट्स में ये रेड चीज़ों में हाईलाइटेड है, ठीक है, वो कुछ की पॉइंट्स हैं या कुछ सेपरेट हैं फ्रॉम द नॉर्मल टॉपिक्स. ओके, इसलिए उसको मैंने रेड में हाईलाइट करके रखा हुआ है. एंड सो फ्रॉम दिस पॉइंट ऑफ यू कैन सी thick film. Okay, for thick film lubrication what we have got the bearings, there are two conditions for thick film lubrication. First is your hydrodynamic and second is your hydrostatic. ठीक है, दो तरह के लुब्रिकेशन हम लुब्रिकेशन का कॉन्सेप्ट हम यूज कर रहे हैं. पहला हमने तो थिक फिल्म थिन फिल्म ये देख लिया. उसके बाद थिक फिल्म, व्हेन वी आर गोइंग टू द डीप स्टडी ऑफ योर थिक फिल्म, वी आर गेटिंग वी हैव टू कॉन्सेप्ट्स फॉर योर लुब्रिकेशन. First is your hydrodynamic lubrication, second is your hydrostatic lubrication. Okay, so एक एक करके हम स्टार्ट करते हैं. The first is your hydrodynamic lubrication. Okay, from the word itself it is clear, hydro means related to fluid, dynamic means related to the motion. Okay, so when there is any sort of motion for the fluid, then that particular concept is called as your hydrodynamics. Okay, thermodynamics आप लोगों ने सुना होगा, that same case is your hydrodynamics. Hydro here is your basically a lubricant. Okay, dynamics means it means to flow. So what is hydrodynamic lubrication? You can say just the definition, the system of lubrication in which the load supporting fluid film is created by shape and relative motion of the sliding surface. Okay, now ये स्टेटमेंट आप लोगों को समझना है अच्छे से कि why we have given the same statement and what is the concept behind the hydrodynamic lubrication. Okay, so first we can say hydrodynamic हमने क्लियर कर लिया. अब हम इस स्टेटमेंट के बारे में समझ लेते हैं. The load supporting fluid film is created by shape and relative motion of the sliding surface. Okay, so what we are getting is, जब आप समझ सकते हैं पहली चीज, एक होता है आप लोगों का शाफ्ट, दैट इज द रोटेटिंग मेंबर. सेकंड इज योर बेरिंग, दैट इज द सपोर्टिंग मेंबर. ओके, ये दोनों मिलके आपकी एक असेंबली क्रिएट कर रही है. असेंबली में एक एलिमेंट अभी हमने जो बताया वो था आप लोगों का क्या, लुब्रिकेंट्स. ठीक है, so when the shaft is rotating and the bearing supports the shaft, okay, so in that case what is happening, there is the self weight of the shaft along with the load of the locomotive or any machine that is being supported on it. Okay, so this constitutes your external load in the shaft that is being provided to the bearings. Okay, वहां से क्या है, शाफ्ट के थ्रू यहाँ पे लोड आपकी बेरिंग में आएगा, बिकॉज बेरिंग इज द सपोर्ट. तो इस सपोर्ट पे आप लोगों की कोई लोडिंग आएगी. एंड व्हेन दैट पर्टिकुलर सपोर्ट हैज इज बीइंग अप्लाइड ओवर एनी क्रॉस सेक्शन ऑफ एरिया, ओके, और यू कैन से एनी सॉर्ट ऑफ एरिया, यूनिट क्रॉस सेक्शन एरिया, देन इट क्रिएट्स अ प्रेशर. ठीक है, सो फॉर दिस हाइड्रोडायनामिक lubrication you can say the, from definition you can see the load supporting fluid film. ठीक है, the load has itself supporting the fluid film is created by shape and relative motion of the sliding surface. So when there is a rotation between the shaft and the bearing, okay, and when there is any sliding action, due to the sliding action, due to you can say the load applied and the cross sectional area, what you are getting is there is a pressure, and due to this pressure the lubricant is being circulated, okay, or the lubrication is being done, okay. There is no any kind of external agency, external pressure applied for you can say the lubrication, okay. So what we are getting, the second point you can see, as the pressure is created within the system due to the rotation of the shaft, this type of bearing is also known as self-acting bearing, okay. ये चीज आप लोग याद रखिए, this is your self-acting bearing. What is self-acting bearing? So hydrodynamic lubrication, or you can say the bearings belonging to the hydrodynamic lubrication concept is the self-acting bearings, okay. और उसका सबसे मेन एग्जांपल जो आप लोगों को स्लाइडिंग कॉन्टैक्ट बेयरिंग्स में पढ़ना है वो आप लोग यहाँ पे देख सकते हैं, दिस इज हाइलाइटेड इन रेड फॉर जर्नल बेयरिंग. सो हाइड्रोडायनामिक बेयरिंग्स आर your journal bearings are under the hydrodynamics bearing, or also called as your hydrodynamic lubrication bearings, okay, or also called as self-acting bearings, ठीक है. सेल्फ एक्टिंग का कॉन्सेप्ट यहाँ पे क्यों आया? बिकॉज प्रेशर का कॉन्सेप्ट अभी आप लोगों ने समझा, यू अंडरस्टैंड द कॉन्सेप्ट फ्रॉम वेयर द प्रेशर इज अराइजिंग, ओके, और प्रेशर इज बीइंग क्रिएटेड हियर. So as the pressure is created inside this assembly or inside the system, okay, no external agency is responsible for that. For that case, this is known as your self-acting bearings. ठीक है, ये चीज को याद रखिएगा. नेक्स्ट आ जाता है आप लोगों का जर्नल बेयरिंग्स. ठीक है, तो पहले ही हम अंडरस्टैंड, लेट मी क्लियर यू व्हाट इज दिस टर्म. बेयरिंग हम देखते आ रहे हैं, बट ये नया वर्ड आप लोगों को क्या आ गया? जर्नल. व्हाट इज दिस जर्नल? यू कैन सी द स्टेटमेंट, द पोर्शन ऑफ शाफ्ट इनसाइड द बेयरिंग इज कॉल्ड एज जर्नल. अभी जो असेंबली में आप लोगों को शो करता है फ्रेंड कि सपोज दिस इज अ शाफ्ट, ओके, this is a whole shaft, but only this portion of the shaft is inside the bearing. So the portion of shaft which is inside the bearing, this particular portion is called as your journal, okay, and this assembly inside the bearing is called as your journal bearings. Clear है? This is the simplest definition for a journal bearing, okay. Now journal bearing, you can say, पहला point हम जो पढ़ रहे थे, we are reading about sliding contact bearing, okay. So journal bearing is your sliding contact bearing. पहला point आप लोगों को मिल गया. नेक्स्ट इज जर्नल बेयरिंग. हम किस सब क्लासिफिकेशन में पढ़ रहे हैं? सो दिस इज योर हाइड्रोडायनामिक लुब्रिकेशन कॉन्सेप्ट, ओके. सो जर्नल बेयरिंग कम्स अंडर हाइड्रोडायनामिक लुब्रिकेशन कॉन्सेप्ट, ओके. एंड नाउ द थर्ड थिंग एंड द वेरी मोस्ट इंपॉर्टेंट फॉर योर जर्नल बेयरिंग इज इट सपोर्ट्स द लोड इज इन रेडियल डायरेक्शन. ठीक है, हमने जो रोलिंग कॉन्टैक्ट बेयरिंग में पढ़ा था वहां पे हमको थ्रस्ट लोड एंड रेडियल दोनों लोड मिल रहे थे, बट इन केस ऑफ द जर्नल बेयरिंग there is the load is applied only in a radial direction. अब इस चीज को आप लोग पहला ध्यान रखिएगा, रेडियल आएंगे आगे जब हम क्लासिफिकेशन और देखेंगे तब हम जानते हैं कि रेडियल किस तरीके से होगा रेडियल डायरेक्शन में, ओके. सो द फर्दर जर्नल बेयरिंग इज क्लासिफाइड एज, फर्स्ट इज योर फुल जर्नल बेयरिंग, सेकंड इज योर पार्शियल जर्नल बेयरिंग. ठीक है, so these two classification are for your journal bearings. So what is full journal bearing? अगर आप लोग देख सकते हैं यहाँ पे, the angle of contact of the bushing with the journal is 360 डिग्री. थोड़ा सा हम यहाँ नीचे डायग्राम में आ जाते हैं. दिस इज योर फुल जर्नल बेयरिंग, ओके. हाउ वी आर गेटिंग दिस फुल जर्नल बेयरिंग? दिस होल शाफ्ट इज सर्कुलेटेड बाय द बेयरिंग इन all the circumference of the shaft, okay, the whole circumference of the shaft. So in that case you can say that it is your full journal bearing, okay. Now what is your partial journal bearing? So in angle of contact of bushing with the journal is less than 180 degree. So when it is less than 180 degree, you can say that it is a partial journal bearing, okay. You can see here this is a shaft, but this bushing is only up to this angle included, okay. From the center if you conclude the angle you may get, but it will be below 180 degree, hence it is called as a partial journal bearing. Now this is one of the most important thing regarding your journal bearing or partial journal bearing. You can say most of the partial journal bearings have 120 degree. Preferable value or suggested value you can say is your 120 degree. Okay, this is not a mandatory case, it depends on the requirement, okay. So this was your partial journal bearing. Now full journal bearing is full journal bearing, but the partial journal bearings, they are further classified. First is your clearance bearing, and now second is your fitted bearings, okay. Now what is clearance bearing and fitted bearing? By the mandate by the name itself terminology it is clear. Clearance means there must be some difference between the two surfaces, okay. So what are the two surfaces? The two sliding surfaces that we are talking about, Okay, and what is this clearance bearing? That is the radius of the journal when it is less than the radius of the bearing. Okay, now you have seen that from this picture you can see, suppose this is the shaft, sorry, this is the center, you can say this is the center for the shaft, this is the center for the bearing. Okay, so when the radius of this shaft, okay, this is your shaft, so when the radius of the shaft is lesser than the radius of the bearing, then it is called as your clearance bearing. But when the radius of the journal is equal to the radius of the bearing, it is called as fitted bearing. From the term fitted itself, you can say there may be some fixing or totally fixed concept. Okay, so on the basis of that, you can say when the radius of bearing and the shaft and the bearing both are same, then it is fitted. When the radius of the shaft is less than that of the bearing, it is clearance bearing. Okay, now you can come to the thrust bearings. What are the thrust bearings? The first is footstep bearing, second is your collar bearing. This all are being categorized under your hydrodynamic lubrication or hydrodynamic kind of bearings. Okay, आगे हम हाइड्रोस्टैटिक के बारे में भी स्टडी करेंगे. So when the footstep bearing, you can see when the end of the shaft is contact with the bearing surface. Okay, is in contact with the bearing surface. So you can see if suppose this is or the shaft, this is the end of the shaft, you can say. So when this end of the shaft is in contact with the bearing surface, or you can say suppose this is the bearing surface and end is in contact with the bearing, then it is called as your footstep bearings. Okay, and the next is your collar bearings. First of all, let me clear you what is this collar. Collar is a sort of supporting member. Okay, what is this supporting member do? This supporting member, one end of this collar is fixed. Okay, one end is in contact with the rotating or the material which has to be rotated or to be supported. Second is it is, and the other end of the collar or the you can other surface of the collar is being connected to the fixed portion or the fixed surface. Okay, so one is the moving, second is the fixed, so this is also acts as your supporting member. Okay, collar. So what is collar bearing? This collar integral with the shaft is in contact with the bearing surface. Okay, so कॉलर बेयरिंग में हम क्या देखें, कॉलर इंटीग्रल विद द शाफ्ट. ओके, शाफ्ट इज योर वन ऑफ योर रोटेटिंग मेंबर. सो वन एंड ऑफ द कॉलर is connected to the shaft. Okay, suppose this is your shaft, this is your collar, so this is connected to the shaft, but this end of the collar, in case of your collar bearing or in case of bearing, when the collar is in contact with the bearing surface, then it is called as your collar bearing. Okay, नेक्स्ट हाइड्रोडायनामिक बेयरिंग्स. ओके, उतना ही हमको स्टडी करनी थी जितना हमने क्लासिफिकेशन में अभी देखा है, और उस ऑन द बेसिस ऑफ दैट क्लासिफिकेशन वी नीड टू सेलेक्ट द कैटेगरी ऑफ द बेयरिंग. ओके, और वी नीड टू डिफाइन दैट दिस पर्टिकुलर you can say the bearing is being categorized under this classification. Okay, so moving on to the next, we have the hydrostatic lubrication. Hydrostatic, okay, when the fluid is in rest, or you can say so okay, on the basis of that we are getting a lubrication technique called as hydrostatic. Okay, but you can see this red words highlighted here, this is externally pressurized bearing. Okay, why it is called as externally pressurized bearing? Let me see the in the definition. It is a system of lubrication in which load supporting fluid film separating the two surfaces is created by an external source like pump supplying sufficient fluid under pressure. Okay, so what makes the basic difference between the hydrodynamic and hydrostatic bearing is, in case of hydrodynamic bearing, there was no external, you can say the agency that pumps the lubricant inside the system. That lubrication inside the hydrodynamic case is being done by the two sliding surface, or due to the sliding contact or the sliding motion of the two surfaces, you were getting the lubrication technique. But in case of hydrostatic lubrication, when you can say the hydrostatic, okay, the static condition is being achieved, but due to this static condition the lubrication has to be fed inside the system. But as the you can say there is no any kind of sliding motion between the surfaces, then you can say there must be some external agency or there must be some external agent that has to fed the lubricant, and that external agent might be your pump or any jet of fluid. Okay, so in that case, when there is external pressure being applied for the lubrication, that is called as your hydrostatic lubrication or your externally pressurized bearings. Okay, that was your journal bearing, you can say, that is self-acting bearing. but externally pressurized bearing are hydrostatic bearings. Okay, and due to the external pressure it is also called as an externally pressurized bearing. Okay, we have seen this two definition, or you can say the 2 points related to the hydrostatic lubrication. Okay, the moving on next, friends, here I want to make 2 minutes of break, you can say. अभी तक हमने जो स्टडी किया था up to the from starting of this video to till now, what we have read is how we are going to do, or what was the basic necessity of classifying the bearings, why we are classifying the bearings. Okay, but now we need to calculate, or we need to study about how we are going to study, or how we are going to select any kind of bearing, or what may be the criteria for selection of any bearing. Okay, so we have got some concept behind that. So we are starting with the same concept. The first one is your Petrov's equation. Okay, what is the Petrov's equation? First statement, you can see it is used to determine the coefficient of friction in journal bearings. Journal bearings you have seen determine the coefficient of friction. Now what comes the question is, what is coefficient of friction? In case of fluid mechanics, in case of engineering mechanics, in the topic of friction, you have read about the coefficient of friction. Okay, if the coefficient of friction is more, there will be more frictional effect. If the coefficient of friction is less, there may be less frictional effect. But you can't challenge the coefficient of friction, because it depends on the surface, or it depends upon the requirement, how much friction or how much frictional component is required in the sliding contacts. Okay, so for deriving the Petrov's equation, we have some assumption. The first one is the shaft is concentric with the bearing. Okay, now a new word has been arrived, that is called as a concentric. What is concentric, or what is concentric circles? You have heard about the term concentric circle. When any two circle or any two element whose center is in a same singular point, or you can say the same point, so that particular element or that your circles are called as your concentric circles. Okay, so we are assuming that the center of the shaft and the center of the bearing are at a single point. Now next is the bearing is subjected to light load. Okay, so we can say the Petrov equation, we have assumed the material will be loaded in a very lighting load. Okay, or you can say the light load, not very heavier load or moderate load. Okay, now let R be the radius of the journal, L is the length of the bearing, C is the radial clearance, and NS is the journal speed. Okay, so what we are getting, radius we have got, length of the bearing we have got, C, let us say it is the radial clearance, and NS is the journal speed. Just I will interrupt you in a middle, friends. Journal bearing, journal speed, what you are reading in this equation, we have derived in respect of its revolution per second. In the question or in the problems, you might be getting revolution per minute or revolution per hour. Okay, so you have to manipulate, or you have to change the formula according to revolution per minute or revolution per hour concept. Okay, now we can say that the velocity of surface of bearing will be given by, the velocity will be given by the circumferential area and how total it is rotating. That basically is the speed. So speed is given by circumferential multiplied by the rotation. So rotation is your ns, 2 pi r is your circumference. Okay, now by Newton's law of viscosity. Okay, now a new term comes who doesn't have read about the in fluid mechanics, that what is Newton law of viscosity. So when you start reading the fluid mechanics topic, the first chapter or the first concept that you have studied is the viscosity. Okay, and then comes the Newton's law of viscosity. Now Newton has given a law for the viscosity, clearly stating that the shear stress is proportional to the velocity gradient of the fluid. Okay, now what is the shear stress, what is the velocity gradient, that you might read in the fluid mechanics, but here you can clearly, we can come to the point that the shear stress tau is given by mu. This is the coefficient of dynamic friction. Okay, that we need to calculate, that what we are going to calculate. And the second is this u by h, this is the velocity gradient. Velocity gradient in case of when you have read in fluid mechanics, that may be given by du by dy, you can say. What is dy? This is the distance, or the, you can say, the difference between, or distance between the two plates. Okay, and what is this du? This is the change in the velocity. So when this velocity with respect to the thickness, it is given as your velocity gradient. So this shear stress is proportional to your velocity gradient. So in this case, this shear force will be equals to mu times multiplied by a multiplied by mu by h. Okay, so shear stress is given by shear force upon area. So shear force will be equals to this shear stress, we can write as PS by A can be multiplied here, so we will get this equation. So from equation 1 and 2, okay, you have got the velocity of the surface of the journal, and second is the shear force. Okay, now moving on to next, if the journal area is 2 pi RL, okay, why this is 2 pi RL? Because journal, what you are getting area is the total portion of the shaft that is inside the bearing is your journal, and total L is, suppose L is the length of the bearing, okay, and this is the circumference. The overall area inside this particular bearing surface, you can say it is the circumferential multiplied by the length. So what you are getting is 2 pi RL is the journal area. Okay, next mu is the dynamic viscosity. Okay, one thing let me clear you. In case of viscosity, we read about basically two types of viscosity. The first is dynamic viscosity, second is the kinematic viscosity. So our main concern of study in this particular topic of your sliding contact bearing is your dynamic viscosity. Okay, mu is the surface velocity that already we have calculated. H is the distance between journal and the bearing surface, and let it is equals to the C, you can say the clearance. Okay, so the shear force, this PS, you can see this PS will be equals to the dynamic friction will be as it is your mu. A we have calculated 2 pi RL, you can put on here. U is given by 2 pi R NS, you have calculated here, and H is equals to the that is the clearance between the sliding surface. Okay, so on the basis of that, what you have got that the tangential shear force is given by 4 pi square R square L mu NS by C. Let's say this is your equation number 3. Now when you have calculated the tangential force, and when this tangential force is multiplied by the radial distance or the radius, then you will get the torque. Okay, so on the basis of that, the torque in the shaft or journal, you can say, is calculated by this shear stress or tangential shear force multiplied by the radius. This gives simply this equation 3 multiplied by your R. Okay, now let us consider a load acting on a bearing with unit bearing pressure P. Okay, now we have calculated the force, we have calculated the torque, and now we are moving on to calculate the basic relation between the friction force and the coefficient of friction. Okay, now let this pressure P is equals to W upon projected area of the bearing. What was W here? W is the radial load acting. Okay, you can see here this W is equals to the radial load acting on a unit bearing pressure P. Okay, so this W upon, you can say this pressure P will be equal to W upon the projected area of the bearing. ये चीज आप लोगों को याद रखना है. What is the projected area of the bearing? Projected area of the bearing is nothing but the diameter and the length. This will be the projected area. Okay, now projected area will be given by 2RL, or you can say the DL. Now this P will be equal to W upon 2 into DL. Now the friction force will be F into W. Why this F into W? What is this F and what is this W? So when you are calculating the friction force, okay, friction force, as you can see, the friction component is given by, let us say, F. So the friction force will be equals to the coefficient of friction multiplied by the load acting. Okay, so here the load is W, frictional component is F. So on the basis of that, what we are getting is this F multiplied by W, and the torque will be equal to the friction force multiplied by the radius. Okay, so this torque MTF, the turning moment, you can say, depending upon the friction component, is will be given by FWR, F multiplied by 2 pi R into R, or F 2 pi R square L. Okay, let us say this is our equation number 5. Now from equation number 4 and equation number 5, what you are getting, both was the condition for the torque. Okay, torque in the, you can say, the journal. So when both these are the torque, we can equate equation number 4 and equation number 5, and you can calculate this 4 pi R square L, R cube L mu NS by C is equals to F multiplied by 2 pi R square L. Okay, and on solving this equation, what you will be getting is this F friction component is equals to 2 pi square R by C mu NS by P. Okay, what is this mu NS by P? This mu ns by p is called as your bearing number, जो हम आगे देखेंगे. We will see in the next topic what is this mu ns by p. So from this equation you will be getting R by C. C is the clearance, ns general speed velocity of C, and p is the unit bearing pressure. Okay. So this equation for F, you can, what you have calculated here, this is your Petrov's equation, and it is used for calculating the friction component in the journal bearing. Okay, यहाँ तक clear है? So moving on to the next, we have studied about the thick film lubrication, we have studied about thin film lubrication and zero film. Thick and thin we have seen. Zero is not too much important for your study point of view for the topic, but when we have seen that if there is a thick film lubrication and there is a thin film lubrication, and what will be the nature of the friction force and this bearing characteristic number, you can say mu ns by p, that was being determined by the Mackey's investigation. Okay, the relation between the friction component and the bearing characteristic number, the mu n by p. Okay, this mu n by p is your bearing characteristic number. Okay, so bearing characteristic number and friction has got the relationship which was defined by Mackey's investigation, that defined the transition from thin film lubrication to a thick film lubrication can be done by mu n by p curve. Okay, what is this mu n by p curve? Simply states, this states that this is F, this is mu n by p. Okay, so on increasing the mu n by p from, let us say this is point B and this is point C, this is point D, and A is the curve that separates the thick film and the thin film surfaces. So on the basis of that, for a particular value, you can say for a particular value up to this point, when you are increasing mu n by p, the F is decreasing. That means the friction component decreases on increasing the value of mu n by p. But at a particular point C, the, you can say the curve will stop going downwards. Now on further increasing the value of mu n by p, the curve moves upward and reaches up to the point, let us say D. Okay, so what we are getting is, according to Mackey's investigation, there is transition, when there is transition from thin film lubrication to thick film lubrication. Okay, so the friction component mu n by p have got a curve in the shape of, you can say, U. Okay, and from this curve you can conclude that this area is, you can say, an unstable area because that curve is decreasing drastically. Okay, or you can say the friction component is decreasing drastically, and without friction you cannot work. That is the you can say the fundamental principle of your natural friction. Okay, so this is the unstable region, but from here you can get the mu n by p is increasing and reach up to the point D, you can say. So this is your stable region. Okay, so Mackey's investigation clearly states that thin film lubrication has the unstable zone and thick film lubrication has the stable zone. Okay, now next is the most important, you can say, the red highlighted topic of the sliding contact bearing, that is the Sommerfeld number. That just you need to remember what is the Sommerfeld number, because it is very much important for your technical exam. Okay, even for your graduation point of view, if you are studying the machine design, Sommerfeld number has got its more important because numerical comes from this topic, clearly stating, or you can say the derive the relation between for your Sommerfeld number. So Sommerfeld number, okay, from the, it is the name of your, you can say, the physicist who given the number Sommerfeld. Okay, it is he is an engineer who has given the concept that the Sommerfeld number S, it derives, or you can say it has the relationship between the clearance R by C, you can say the radial and the radius and the clearance with respect to the bearing characteristic number mu ns by p. So on the basis of that, what Sommerfeld has calculated, that this value s or the number, first of all you can see I have clearly written here, this is a dimensionless number. Okay, so the Sommerfeld number is a dimensionless number. Second, it has a relationship between the radius and the clearance along with the bearing characteristic number. Okay, so this mu ns by p r by c whole square. Now what you may face in the question, that for a Sommerfeld number, condition may be given that this r by c is constant. So when, you can say, if the coefficient of friction is increasing and keeping the other two elements constant, what will be the changes in the Sommerfeld number? It will decrease, it will increase, it will remain constant, it will be zero. So if this mu is increasing, you can say this S has a directly relationship between mu. So when it is directly proportional, you can say if mu increases, S increases, and further vice versa for the other elements of this formula. So this Sommerfeld number is given by this S is equals to R by C whole square mu n S by P. Okay. Now the next is your Raimondi and Boyd method. What was this Raimondi and Boyd method? Why it came to existence? Why they have given a separate concept for your sliding contact bearing or sliding contact? Because at the end you can say they have calculated the minimum film thickness variable. So their experiment was based on a concept. Petrov's equation, we have assumed that the you can now, first of all, we can differentiate between the Raimondi and Boyd method and the Petrov's equation. What we have done in Petrov's equation, we have assumed that the shaft and the you can say bearing, they are in concentricity they have maintained. But in case of Raimondi and Boyd method, Boyd experiment, what they have got is when the shaft is in rotation inside a bearing, there is some eccentricity of the center of the shaft from the center of the bearing. Okay, and in order to that, or in calculation for that, Raimondi and Boyd had made a conclusion for the minimum film thickness ratio. Okay, so what they have done, let us say this is the overall, you can say, the assembly. This portion, this solid portion inside, this is your shaft. Okay, this the hashed portion is your bearing. Okay, so let us say the C is the radial clearance, R is the radius of the bearing, and R is the radius of the journal. You can see this E, this is nothing but the eccentricity of the center of the shaft from the center of the bearing. Okay, now according to this eccentricity ratio, what you can calculate is this is given by how the eccentric is and how much is the clearance. This is epsilon is equals to small e by C. Okay, so this capital R, now we have come to the radius of the bearing. This radius of the bearing will be given by this E, from you can calculate up to this end, E plus R plus H0. Okay, this H0 is nothing but the film thickness, you can say. Now this C is equals to R minus R, clearance is equals to inner radius minus outer radius. Already we have seen in case of your clearance bearing. This is equals to E plus S0. Okay, now on equating this equation, this whole equation, what we are getting is this clearance is equals to 1 minus epsilon is equals to S0, or epsilon is equals to 1 minus H0 by C. Okay, so from this equation, what we can conclude, or what Raimondi and Boyd method has given us, is this H0 by C is called minimum film thickness variable. Okay, so why we are calculating, or why we need to calculate this H0 by C ratio? Because we have studied about thick film lubrication, and on the basis of this thick film lubrication, when you are going to design a bearing, okay, so this H0 by C has got its own table, you can say, where you need to calculate the H0 by C, or you need to just find out the value of H0C, and you can calculate the eccentricity of the bearing, how much eccentric you can keep your shaft from the bearing center. Okay, so the next is your bearing design parameters. This is a short of your one-liner thing, or one-liner theoretical part that you need to keep in your mind for your technical exam. So the first is the length to dia ratio of the bearing. So length of the bearing has more load carrying capacity. So L by D when greater than 1, this is given by long bearing. L by D less than 1, this is short bearing. L by D equal to is known as square bearing. Okay, and this is one of the key point, you can say load bearing has more long bearing has more load bearing capacity or load carrying capacity. Okay, next is the unit bearing pressure. Already we have seen this P0, what we have calculated in Petrov's in your equation is the load per unit area of, the load per unit of projected area of bearing in running condition is called as unit bearing pressure. Okay, first of all, this pressure is depending upon the projected area, not on the cross-sectional area. This you need to keep in your mind. Okay, the next is the startup load. It is stored when load shaft is stationary, used to determine minimum length of the bearing. Okay, why this? There is a need of startup load, you can understand. So when you are going to assemble the bearing, or you can say the shaft and the bearing assembly, so what we are doing is we are providing some initial, or you can say the static load initial present in the shaft, okay, in order to provide the assembly. So it is a static load when shaft is stationary. Okay, it is used to determine the minimum length of the bearing. So why we need this startup load? Because on the basis of that you can get the length of the bearing. Okay, next is the radial clearance. Radial clearance nothing but should be small to provide the necessary velocity gradient. Okay, in case of your Newton's law of viscosity formula, what we have seen, the shear force was equals to mu a u by h. H was the clearance. This clearance should be minimum. Okay, so this should be either, you can take the standard value as c is equals to 0.001 times of the radius. Okay, next is the minimum oil film thickness. Surface finish of the journal and bearing is governed by the value of minimum oil film thickness. Okay, this is one of the key point. Surface finish of the journal and bearing, okay, is governed by value of minimum oil film thickness, and this H0 is equals to 0.0002 times of the radius. Okay, the next is maximum oil film temperature. Study we have previous, in the previous concept we have read about the thickness, but there was no any kind of query regarding the temperature. So here comes what may be the maximum oil film temperature. This, in case you can say, the limited temperature is 90 degrees Celsius, which is kept for the bearing. Now if the value increases, then what you can do, we can provide some coolant, or we can provide some any sort of lubricant that has its own self heat dissipating capacity. Okay, and on the basis of that, in order to you can say to bear the temperature, you have the bearing materials. Okay, this bearing made of a Babbitt material. Okay, what are Babbitt material? This is one of the most important theoretical question about bearings, that is asked many of time in your technical exam when you have got the topic of bearing. Okay, so let us see the most popular bearing material is your Babbitt. What is this Babbitt material? It is a sort of, you can say, an alloy. Okay, it has a silvery appearance, and the Babbitt is called as your white metal. First of all, why we are using this Babbitt material? Okay, the question arises why we are using this Babbitt. So the first important property that you can see is excellent conformability, and the second important property is its excellent embeddability. Okay, embedded word you have heard in English. This embedding is nothing but it can be easily embedded to any of the material. Okay, so in if your external or internal radius, other than your bearing material, you can say the stationary part, you can say the rotating part, if they are made of some you can say the metal. So the metal, if in order to you can say fix the material from the stationary material, it should be, okay, you can say it should be easily embedded in the fixed part, okay, or you can say the fixed structure, so that the assembly could be many much durable, or you can say it has to be more efficient. So it has got its excellent embeddability. Second is excellent conformability. What this conformability word clear, you can say, friend, conformability is nothing but providing a durable life, or providing an efficient life, okay, for the bearings or for the assembly. Now this Babbitt material, okay, it is made of basically two different bases, you can say. It is a sort of alloy has got some base. Okay, so the first case is your lead based alloy, second is your tin based. So Babbitt, when it comes for a lead base, it has got temperature increases, strength decreases. Okay, so for the lead based alloy, you can conclude a point that if the temperature will increase, the strength of the bearing will decrease. Now the key point, or you can say, for you can say the tin based alloy, why they are most preferable, just because they have got better corrosion resistance, and second is easily bonded to shells. Okay, so the tin based Babbitt materials are more preferable over lead based Babbitt material. Okay, so friends, this was the basically, I just conclude the video from here. This was the basically the concepts of your sliding contact bearing. From starting, I just want to revise you in just a single minute. We have read about the why sliding contact came in action, what was the kind of lubrication, what was thick film, thin film, and zero film lubrication. Then comes your hydrodynamic lubrication, then comes your hydrostatic lubrication. Okay, this was the broader classification about your sliding contact bearing. Now comes why we are reading. So how we are going to read, or what was the basis of reading this? So we have got the Petrov's equation. Okay, after that we have read about the Sommerfeld number, and then we have read about the Raimondi and Boyd method, and then we have got the Mackey's investigation. On the basis of all these four issues, we can go for the selection of the bearing. And at last but not the least, we have read about the design parameters of the bearing. What should be the standard clearance, what should be the standard, you can say, the film thickness, what may be the material, and last but not the least, the most important thing about the bearing material was the Babbitt material, and why we are using and how we are using. Okay, so friends, this was the concept for your sliding contact bearing. I just conclude the video just with a request that I need the feedback, or I just need a comment from your side that how the content goes for all those videos, or basically for this video. And just I request you to share my videos, like my videos, and subscribe to all those who need the you can say the study, or you can say the landmark, where you can get all the videos regarding your technical section. Okay, thank you friends.